Dear friends and viewers, welcome to Kns Biochemistry. This is Dr.K.Narayanasamy, Associate Professor of Biochemistry, Nehru Arts and Science College, Coimbatore. So I am happy to invite you all for this session on micronutrients. Micronutrients are highly essential, very important, but at the same time they are required in lower quantities only. So in that lower quantities they are going to play a very essential role in the body. So in this video session I am going to talk about one of the important micronutrients which is highly essential in our body system, especially in the metabolism and hormonal and enzymatic reaction. That is nothing but the major micronutrient calcium ion. So in this session we are going to discuss about calcium ion and its metabolism. So calcium ion metabolism is a very important prominent metabolism that is taking place in our body. So these metabolisms are highly interrelated and it is highly essential for other metabolism which are connected with this calcium metabolism. So let us see the session now. Please come along with me. Micronutrients. So micronutrients are essential minerals needed for our better functioning of the body as well as the betterment of the metabolism. Calcium is one of the major micronutrient which is needed for us. Without this calcium ion, it is impossible, it is very impossible to have our normal metabolism. So let us start discussing about this calcium first. So here we are going to see some of the topics areas here, that is calcium ion and its role in cellular processes, then calcium absorption, the absorption mechanism of the calcium, then after absorption what is going to happen to this calcium, that is the calcium distribution process. Then once it is distributed, how it is maintained, its balance is maintained, that is called calcium homeostasis. And then some quantity of calcium when it is excreted, that is it is taken to the kidney cells, where what is the fate of this calcium, that is the reabsorption of calcium by tubules. Then the role of some hormones. These hormones are regulatory hormones which regulates calcium level in the blood. So all these areas we are going to discuss now.
Ion, Ca2+, divalent cation, Wikipedia, calcium in the human body, fifth most abundant element in the human body. After cremation, a third of the remaining mass, 1 kilogram, makes up 70% of hydroxyapatite, cotton PO4602. Most is present in this fixed form, bones and teeth. A little is in the cytoplasm of all the cells. A tiny amount circulates bound to albumin. Minuscule portion is circulating as Ca++ ion. The only physiologically active form is the Ca++ ion. Endocrine physiology, 3rd ed. P.E. Molina, Chapter 5, Dichap. Distribution of calcium in the human body. 1% of total body calcium is present in the cells. 0.1% of total body calcium is in the extracellular fluid. Ionized calcium, Ca++, 50%. 1.2 millimoles/L. present as free, active cation. Diffuses easily across capillary membranes. Hydroxyapatite, 98.9%, equals 31 moles, equals 1,250 grams, 1% of which is available as an exchangeable pool. Protein-bound calcium, 41%, 1.2 millimoles/L, bound mainly to albumin, cannot diffuse across capillary membranes. Anion-bound calcium, 9%, 0.2 millimoles/L, bound to small anionic molecules, e.g. phosphate and citrate, diffuses easily across capillary membranes. Guyton and Hall Textbook of Medical Physiology, 11th ed., J.E. Hall, Chapter 79. What are we measuring, exactly?
So calcium ion in cellular processes. So when you take any cellular mechanism, any type of cellular mechanism, you see that calcium plays a very important role. See, the calcium ion, that is a Ca2+, it is a double cation, Ca2+, which is distributed everywhere inside our body in all the cells. So that is why it is abundant cation, that is Ca2+, which is present and distributed in our body. That is if you see that it's a distribution, approximately 1000 grams of calcium ion is distributed in adults, normal adult human being. So since it is distributed everywhere in all the cells, you have to intake calcium regularly in our daily food. So the requirements, the daily requirements per day for the normal human adult is 1000 to 1500 milligram per day. So now if you see this table, the table gives you an overview or bird eye view about the composition of these kind of minerals and some of the essential components present in our whole body. So now you can start from one end. See, body weight. Suppose we are taking a human being, a person with a 70 kg body weight. So 70 kg body weight human being. In that person, it is determined by chemical analysis, and the values per kilogram fat-free tissue is calculated. So per kilogram whole body weight, what is the distribution or composition of these components in our body? For example, water in grams. Water is needed 605, that is 605 grams. It should be there for a body weight of a person who is having 70 kg. Similarly, fat 160 grams. Water, that is water inside the cell, outside the cell is also there, 720 grams. Then nitrogen 34 grams. Then sodium, Na. Sodium is needed only in milli equivalents. Milli equivalents is very low value, not in higher quantities like in grams. Milli equivalent, sodium in milli equivalent, 80 milli equivalent is required. It is there. Then potassium ion 69 milli equivalents.
kg/day, intravenously. Thus, a 100 kilograms ICU PTN needs 10 millimoles every day. O's Intensive Care Manual, 6th ed. R. Leonard, Chapter 87, Enteral and Parenteral Nutrition. Usual sources of calcium. Dairy. 200 milliliters yogurt equals 10 millimoles. 1 liter of milk equals 25 millimoles. Spinach. Baked beans. Oranges. Nuts. Small canned fish with intact bones. Canned sardines equals 10 millimoles per 100 grams. www.nutritiondata.com. Unusual sources of calcium. Every 1 calorie contains till to 23 millimoles of calcium per liter, 910 milligrams. 1 caltrate tablet equals 15 millimoles, 600 milligrams. Calcium resonium, exchanges calcium for potassium in the gut. Calcium content is 1.6 to 2.4 millimoles/g, so each 30 grams dose equals potentially 48 to 72 millimoles. Calcium gluconate, 2.2 millimoles per 10 milliliters vial. Calcium chloride, 6.6 millimoles per 10 milliliters vial. http://www.havennutrition.com.
So thank you very much for your patient listening, and once again if I get another opportunity, I will meet you all with another topic in another video session. So thank you all. Jai Hind.